Hi guys, this is Mohit from Indian iOS Guru, and this is our 11th video of our Learning to Build iOS Apps with Swift series. And in this video, we'll be looking at properties. So as the literal definition goes, properties add characteristics to classes, structures or enums. Swift has two kinds of properties: stored properties for storing constants or variables as part of the instance, and computed properties to calculate the value of the property. It's important to note that classes, structures and enums can have calculated properties, whereas only classes and structures but not enums can have stored properties. Swift also allows us to define property observers that let us monitor the changes to a property's value. So let's look at stored properties. So for example, I have a struct called point 3D. It has an x coordinate of type int, a y coordinate of type int, and a constant z coordinate also of type int. So now to create an instance of this struct, we can say var point A is equal to point 3D, and I will use this member-wise initializer for structures that we have seen in the previous video. So I can say for x 5, for y 7 and for z 10. So in this example, z is declared as a constant and cannot be changed, but x and y can be changed. So if we want to alter the value of x, I can say point A dot x is equal to 6. So let's look at another example. This time I'm going to create a constant point B and say point 3D, and I'm going to say 1, 2, 3. So in this case, even though x and y are variables, we can't change them because point B is a constant and structures are passed by value. So there's no way I can say point B dot x is equal to 5. And there you go, Xcode is giving an error. It says cannot assign x in point B. So if you want to change individual members of the structure, make sure you declare the structure as a variable. Declaring it as a constant is not going to allow you to change the individual members even if they are declared to be as variables. So when a structure is declared as a constant, all its properties are also constant. This is not true for classes, as classes are reference types. So let's talk about lazy stored properties. As you can see here, x, y and z are stored properties and they are part of the instance, and each instance has its own copy of x, y and z. So a lazy property is one that is not initialized until the time somebody tries to access it for the first time. So for a property to be initialized lazily, it should be marked with the lazy keyword. Lazy properties are useful when the initial value of a property depends on external factors, for example, fetching values from a server or when some complex calculations are required. So for example, let's create a class called RSS fetcher. In this class, I'll create a lazy property called RSS array, which is nothing but an array of strings, and let's initialize it. Let's create a function called function sum complex logic. Now this function returns to us an array of strings, and in this function let's put in a hard-coded array of strings which says hello RSS. Let's create another function which will fetch the RSS feed for us, and here I'll say RSS array is equal to some complex logic, and let's print out the RSS array. So this property RSS array will not be initialized until this line of code is executed. So when even though an instance of the class is created, this property is not created for us, and since its value is going to change at runtime, it is obvious that lazy properties should be marked as variables. So to see this in action, let's create an instance of this class. So let's say let RSS fetcher is equal to RSS fetcher and use the initializer syntax. Okay, let's just try to print out RSS fetcher dot RSS array. Oops, this has to be small RSS. You can see here I am trying to access the property, so it got initialized with 0 elements, but over here, even though the class got initialized, the property did not get initialized and it's pointing to nil. So let's go and say RSS fetcher dot fetch RSS, and now you can see that hello and RSS are part of the instance of the part of the property that we created. And let's just print out RSS fetcher. You can see we get the output. So let's talk about computed properties now. So as discussed before, classes, structures and enums can have computed properties along with stored properties. Computed properties are those that do not store values themselves but provide accessors, that is a getter and a setter, to get and set the value of the property. So for example, let's say I have a struct. Let's call this struct circle, and I'll say create a variable radius of type double, and let's just initialize it to 0. Let's say let pi equals 3.14, and let's say create a variable called area of type can be double, and I open a set of curly brackets, and within this I will say define the getter, and I'll say return pi into radius into radius. So whenever somebody tries to get the area property, it will calculate the area and return it to the caller. And let's create the setter. So whenever somebody tries to set the area, we have to obviously update the radius. So we'll say radius is equal to new value. So new value is a system defined parameter for the setter, and new value is basically the new value that somebody is trying to set to this property of ours. So we can say new value divided by pi into radius. So let's see how this works. Let's create a circle is equal to circle. Let's say circle dot, okay, what's the problem? Okay, so it looks like from one of my previous codes I've already created a variable called circle, so let's call it circle x. Circle x dot radius is equal to 5.6, and now let's say print ln area, and I'll print out circle dot area. So on this line, what's the problem? Oops. So on this line, when I am saying circle dot area, circle x dot area. So when I'm saying circle x dot area, it will execute the code in the getter. It will do this calculation of pi into radius and print out the value for me. And at the same time, if I say circle x dot area is equal to 89.5, and now when I say print ln radius circle x dot radius, you can see the radius has changed to 5.0898 from 5.6. So when on this line of code, the setter got executed and the code in the setter updated the value of the radius property for us. So from this example, it's obvious that computed properties should be declared as variables and not constants. We can also have read-only computed properties by only implementing the getter and not the setter. In Swift, we also have something called property observers, and as the name suggests, property observers respond to changes in a property's value and are called every time the value of a property is set. So property observers can be added to stored properties but not to lazy properties. So the two property observers are will set, which is called just before the value is set, and the other one is did set, which is called immediately after the value is set. When we implement will set, the new value of the property is passed in with the name new value, just like over here as we've seen. And similarly with did set, the old value of the property is passed in with the name old value. So let's look at an example for this. Let's create a class called calorie counter. In this class, I can say total calorie intake of type int and just initialize it to 0. Again, open a set of curly braces and say will set, and here I'll put in a print ln. The new value is new value, and I'll put in a did set, and from here I can print out the old value. So I'll say the old value is old value. So let's create an instance of the calorie counter class and see how it works. You can say let cal counter is equal to calorie counter, and we can say, you can see total calorie intake is 0 now. and I'll say cal counter dot total calorie intake equals 250, and you'll see on the right hand side total calorie intake gets updated to 250, but we don't see the println lines, the output being printed out, because this being the storyboard. But in an actual code, in an actual app, the will set and did set would get executed. But just for another example, I can say cal counter or total calorie intake is equal to 300. So you can see here, even though cal counter is being declared as a constant, I can still update its properties, because as I mentioned before, classes are passed by reference. So for everything that we have seen related to properties, it all has been applied to global properties, that are properties accessible throughout the class. So whatever we have seen can also be applied to local variables, that are variables that belong to a function, method, or closure. So the getters, setters, the property observers, everything can work for local variables as well. Swift also has something called type properties, and up to this point we have encountered instance properties, that are properties that belong to the instance, and each and every instance that is created will have its own copy of the properties. Properties can also be created so that they belong to the type, that is the class or the structure or the enum, so that every instance created of the type are accessing the same value of the property, as there can only be one copy of that property. This makes the type property universal to all instances. However, it is important to note that we can have stored and computed type properties for structs and enums, and only computed type properties for classes. So type properties are declared with the static keyword for structures and enums, and with the class keyword for classes. So for example, I create a struct called chessboard struct, and I create a type variable called let number of tiles equal to 64. So what it means is, no matter how many instances of this chessboard struct are created, whenever they try to access this property number of tiles, each one of them will get a value of, will be accessing the value 64. And let's see this for a class. So I'll say class chessboard class, and I'll say class var number of tiles, which is an int, and I'll say return 64. So what this means is, for every instance of this chessboard class that is created, if that instance is trying to access number of tiles, it is also always accessing the value 64. And as I mentioned before, for classes we can only have computed type variables, and this line where I have directly said return 64 is the shorthand getter syntax. So to access these type properties, we can say println chessboard struct dot number of tiles, we access it on the structure itself, and here we say chessboard class dot number of tiles number, and this is also going to print out 64. So this is the end of our 11th video. I hope you enjoyed it. The code for this video will be put up on GitHub, and the article will also be posted on our website, Indian iOS Guru. We will also be doing a Q&A session for the videos that we are making. So head over to our website, Indian iOS Guru, for the Q&A session. Thank you.